In sport facilities, we can have different lighting systems. Today we see the main types with pros and cons of each one. First of all, we have the metal halide lamp. Inside this lamp we have a small bulb, the white one, with two metal electrodes and a mixture of vaporized mercury and metal halides, in particular sodium halide. If we turn on this lamp using an electric current, between the two electrodes we have an electric arc which heats the gas inside the bulb and creates light. This technology was developed in 1960s and used in sport facilities from 1990s up to 2010, more or less. Today it's not used for new facilities, but we can find these lamps in all the lighting systems. The main problem with this lamp is its lifetime. It has a lifespan from 6,000 hours up to 15,000 hours, more or less. If the lamp is installed in vertical position like this, its lifespan increases, but this is not very common in sport facilities. It has also a high decay. What does it mean? When the lamp is new, it emits 100% of its light, but time after time, if the lamp is turned on, this light decreases. After 2000 hours, its light is more or less the 80% of the original one, and this is a high decay for a lamp. In addition, when the lamp is turned on, the electric arc creates high pressure because the gas is hot inside the bulb, and if we turned off the lamp and then on again rapidly, the electric arc cannot be formed because we have high pressure. This means that we need to wait 10-15 minutes for the lamp to be cooled down, and then we can turn on it again, and this is a big problem in sport facilities. This lamp is often installed in a floodlight with 400 watts and a ballast. A ballast is an electronic component to limit the amount of current which flows inside the lamp to avoid damages. The electric efficiency of this lamp can vary from 75 up to 100 lumen per watt. It means that each electric watt of power that we pay and supply to the lamp will emit 75 or 100 lumen of light. The light this lamp emits goes in all directions with respect to the main axis of the lamp. So a part of this light will not go on the direction we need to light the structure, but in the opposite. Floodlights have a mirror made of steel to re-emit part of this light, but another part is wasted. So the real lighting efficiency is lower than the datasheet one. At the end of its life, the small bulb can burn out with flickering, change of color of light, and in some cases the explosion of the small bulb. Then we have electromagnetic induction. Tesla patented it in 1890s. A lamp is a toroidal, so like a donut, with noble gas inside of it and a fluorescent coating. The lamp has no electrical contacts but two external coils. These coils with electromagnetic induction ionizes the noble gas, which emits ultraviolet rays. In response, the fluorescent coating emits the visible light, so it translates the ultraviolet light in visible light. A normal electromagnetic floodlight has no flickering problems or turn off and on problems, but it requires a ballast to limit the current. The main advantage of this lamp is its lifetime. It can span up to 100,000 hours with a low decay around 20% after 9,000 hours. It's also dimmable, so we can partialize the lighting power the light emits, and it's very useful in a situation where we have a high power of lights, for example, because we have international tournaments, but very often we don't need all this power, so we can dimmer the lights and supply less power to the lamps, and so pay less for the running costs. As regarding the lighting efficiency, it has a lumen per watt ratio spanning from 65 up to 90 lumen per watt, and even in this case we emit light all around the main axis, so the real efficiency is lower. Last but not least, we have LED floodlights like this one. This is a technology invented in 1927 by Oleg Losev, and LED stands for light emitting diode, so a diode, a silicon wafer doped with other materials to modify its chemical properties, which allows the current in one direction but not in the opposite one, and differently from other type of diodes, this one can emit light if a current passes through it. This type of floodlights are competitive in the sport industry since 2010 more or less, when their lighting efficiency had improved a lot and their cost dropped, and this is due to the huge amount of money the producer spends on continuous improvements. So nowadays is the de facto standard not only for sport industry but for lighting in general. The main advantage of LED is the super high lighting efficiency with 180 up to 200 lumen per watt, which is nowadays a normal value. In addition, lighting emission is directional, so all the lights goes in the direction we want. And a floodlight is also very cheap and light, and can be easy dimmerable. The duration of a floodlight like this one is between 30,000 up to 50,000 hours. It has no flickering and a decay around 20% after 20,000 hours. So as duration and decay, it's better than metal halides, but not as good as electromagnetic induction. The main enemy of the LED is heat. This because overheating can break the LED, and this is the reason why we have this heating dissipation system in floodlights to avoid damages. In addition, LED can cause glaring. So these are the main technologies in sport industry for lighting. If you have metal halides, I will at least consider the change in favor of LEDs. And as always, I hope this video is helpful. If you have doubts or questions, down in the comment or on our website, and see you in the next video.